All right, chapter 8 in your textbook is entitled Sinusoidal Functions. That's right. Sinusoidal functions. Shh. Girls, hey, get your books open. Let's go. Come on. I asked you 5 minutes ago to do that. Yeah. Page 511 is where it starts. If you notice on page 511, we have a picture of the moon, okay, and all of its phases there. It says the moon appears in a cycle of 8 phases. A different percent of the moon is illuminated during each phase, except the new phase. No part of the moon is illuminated during the new phase. This cycle repeats every 29.5 days. Suppose you are asked to draw a graph to represent the percentage of the moon that is illuminated during each phase. So if we had the phases of the moon, 1, 2, 3, 4, 5, 6, and so on, 8 phases of the moon, and this was 100%, okay, of the moon that's illuminated. So full moon, right? Where's the full moon? Which phase is that at? Right in the middle. Okay, it's 1, 2, 3, 4. So we got 100% here. Okay, and if you look on the little diagram there, it actually shows you sort of percentages, or the little bits of the moon that are illuminated. And so if we were to estimate that, the first phase would have a really small percent. The next phase, larger, and so on. And then the full moon, and then it'd come back down, right? So it'd look kind of like this. And then the new moon would be 0, I guess. Okay? So if you were to graph this out, it would look sort of like this. Right? Like that. And then it would turn around and come down like this. And so this is an example of a sinusoidal function. It's a function that when you, first of all, it's repeated. Okay, it repeats itself. Okay, it's also called a periodic function, but it's in the general shape of a sine graph. That's what it's called. Why it's called sinusoidal. So from here, come to here. If you look at this kind of part of the graph right here, oops. Okay, let's make that a little prettier. Okay, it kind of looks like what you call a sine graph. Okay, sinusoidal. So that's what this chapter is about. And the first section is understanding angles. Okay, so angles and a sine function, they're closely related. Does anyone know what other kind of function gives a sinusoidal shape function? Cos. Anything else? Well, tan is the other one. Is the other primary trig ratio? Yeah, but it doesn't give this sinusoidal. Just sine and cos. But yeah, good guess. So the sine function and the cosine function give you this certain shape of graph. Okay, so 8.1, we're talking about angles. And obviously, the first unit for an angle that you all know about is degrees. Degrees. How many degrees in one full circle? Yes. There are 3. That was weird. There are 360 degrees in a complete circle, or let's say in one full revolution. Okay? Let's change that. In one full revolution. Okay, so yeah, different. Great question for history class. Okay, so if we start here at this line right here and we go up and around, right? The full trip around here is 360 degrees. So that means that there would be 360 discrete stops along this revolution, and each of those would be 1 degree. right? So what's halfway around from 360 then? 180, right? So if you draw an angle that is a flat angle or a straight angle like this, that's a 180-degree angle. Okay? So if someone does a 180-degree turn, they go exactly the opposite way that they were going, right? A full 360, right? One complete turn around, so they face the same direction. You know, that kind of wording. All right. So what's this one right here? That splits that in half? Yeah, that's 90. What about this one? It's, yeah, so this is 90. This is plus another 90. This is another 90. So 180 plus 90 is 270. Okay? There's too much wind coming through those windows. You can put them down a little bit. It's blowing anybody's papers off. So 270 plus 90 again is 360. Okay? All right, so any questions about that? What would you guess this angle to be right about here? 20, 45, 43. Yeah, it's not a perfect circle, obviously. So yeah, so around 45. You said somewhere between 42 and 48, maybe. But yeah, okay, that's good. What about this one? What would you guess this angle to be if I went all the way around from? Okay, all right, 276.3. Okay, approximately. Okay, so if we have 45 here, this would be about 22 and a half, right? And then half of that would be about 11, so maybe I was going for 10, I guess. 278, 280, something like that. Okay. All right, so we know degrees, right? What if you go 2 full times around? You spin around not once, but twice. Yeah, that's 360 times 2, right? So 720 degrees. Very good. Does anyone know what happens, how that angle, how the name or the size of the angle changes if we go a different direction? For example, what is this angle right here? If I go the opposite direction? Yeah, okay, you had it right there. You're on the right track. All of these numbers that I drew, were and wrote down were positive numbers. Would you follow reference angles? Okay, good question. Yeah, what I was going for is that the different direction this is positive direction. That's a positive 90. This right here would be a negative 90. So anything that goes clockwise is actually negative. Anything that goes counterclockwise is positive. So why don't we write some of that down here? Okay, so angles in a counterclockwise direction from 0. So that's this right here, going this direction. Okay, any of these angles here going in this direction are positive. If the angle goes in a clockwise direction, so that's like this down here, the 90 and so on in this direction, are negative. Okay, questions about that? Some basic stuff there. Now, most of this lesson is not going to be about degrees, but it's going to be about another angle measure that you might not have ever heard of before. And this angle measure is called the radian. Okay? Radians. So I'm not sure if you noticed on your calculators that you have a kind of a mode on your calculator that looks like this, but also one that looks like this. This is degrees. This is radians. So remember how up to this point, if you're trying to solve a trigonometric, equation or something, trying to find your angle, I've always stressed that you have to be in degrees, right, with a D, and not radians, or not a big R on your screen. So this is the other kind of angle. All right, and it has its place in math. It's actually quite important, and I'll just give you a little brief summary as to why it's important. Ah, nice circle. Okay, so if we look at a circle, right? Do you guys know what the circumference of the circle is? Anyone tell me? Anybody heard that word? Okay, pi d, yes, it is. Circumference equals pi d, but what is the circumference? It's like the perimeter, yeah. It's like the perimeter of the circle. So circumference is pi times diameter, that's absolutely correct. What's another way to express the diameter of a circle? Well, diameter actually equals 2 times the radius, okay? So the circumference of a circle also can be written as 2 pi r, okay? So if the radius, let's say the radius equals 1. If the radius equals 1, and in pre-calculus, we talk a lot about the unit circle. And this is a circle with radius 1. So it's the unit circle. And in the unit circle, if this r is 1, then guess what? The length, the distance around the perimeter of the circle is actually 2 pi. Okay? So that's important. All right? Now, what is 2 pi in decimal form? It's approximately equal to what? Okay, what's pi? Remember, pi is 3.14159, so on, so on, so on, right? Forever. So 3.14, let's say. And 2 times that is about 6 point, what'd you say? Yeah, 6.28. Okay? So that's about 6.28. So if you look at this circle, okay, what you notice is that as far as, if this is radius 1, the distance around the circle, all the way around the circle, is about 6.28 units. If this is 1, this is 6.28. And that ratio, radius 1 to circumference 6.28, that is the same for every single circle. If you have a circle with radius 2, then the circumference, or the distance around, will be 12.56. It'll be double this. And if you have radius 3, so on. It'll be 3 times this. So there's a special relationship there. And this pi unit is a special constant that is a constant for all circles. Every shape that is a perfect circle has this constant pi that you can use to calculate its area and circumference. It's a special factor for circles. Okay? Now this is all just a background setup, okay? So just be patient. You guys are doing great. Okay, so look at this. What I'm going to do is I'm going to draw another diameter here, another radius that looks about like this. And of course that's radius of 1 as well, because it's the same circle. It's not a very straight line. Sorry, let me try that again. But something right about here. Okay, that's radius 1. This is radius 1. And the reason why I drew that particular section of the circle is because what I was trying to do is I was trying to get this part of the circle from here to be about the same length as the other two. So it's kind of close. I'd actually like to try this just one more time and make this just a little bit bigger. Now my circle obviously isn't perfect, but I'm looking at this, and this is not a triangle because this side right here is like rounded out, right? It's part of the circle. But this is a special angle right here. That's a special angle where the 3 parts are all the same. And I want to direct you to the bottom of page 514 there. And the definition of a radian, okay? That definition is this. So the definition of a radian here from that page, again, is this. The measure of the central angle. So this right here, this central angle of the circle subtended, okay, or contained